Hello and welcome back to Advent of Code. Today we'll be doing day 6, but before we jump into it, I just want to show you I've done a bit of refactoring on the input logic. So I've created this new file called inputhelper.h that has a function called readPuzzleInput, and it's kind of similar to what we've been doing every day, which is open a file. If we can't open it, we print an error message, return false, and then we do our loop for each line. So while we're not at the end of the file, now I've got you could call this function called handleLine. This is actually a function pointer. So in our function signature for readPuzzleInput, we do pass in, basically we pass in another function into this one, and that function will handle scanning each line. So if I come back to day 5, yesterday, here I'm doing readPuzzleInput. We give it the file name, we pass it the line count integer, so it can count how many lines it's given, our array. Then we pass in this, which is our own custom function, and all this custom function does, what we do is we get back the actual file handle, that count. So this count variable here points to the same data in memory as this variable here. And then you'll notice it gives us, if you've not used void star before, it's an unusual thing. Basically this means this can be any type. We don't know what the length, the size of this type is yet, but because we know we passed in our array of lines, what we can do is we can cast this back to the type that we already know it is. And this basically means that our readPuzzleInput function is generic. It doesn't have to care about what kind of data we pass into it, because it just basically forwards it back to the caller. If that makes sense. And this line here is just defining our function pointer. So we just need to define what the signature of that function is. It's a function that returns a boolean, and it gives a file pointer, an integer pointer, and that void pointer there, that any type. And that just tidies things up a little bit. Our reading logic is now a lot easier. It's just these few lines here. If I go to day 1, you see here it's calling scan. The same thing, readPuzzleInput, give the file name, values count, the list of values. And then I've put this inside the helper function because I'm just guessing it's going to be quite a common thing where we just want to read a list of integers from a text file. So we might as well go in the helper function. So now that's out of the way, let's get ready for day 6. So I'm just going to do day 6, let's see. We're going to have our day 6 function. I'm just going to comment out everything else. We're going to create that file, day6.c, which is going to have our day 6. Result is, and we don't know what the result is going to be yet, we'll just put that as a placeholder. And then we are also going to create our input day6.text ready. So let's head to Advent of Code day 6. Alright, Lanternfish. The seafloor is getting steeper. Maybe the sleigh keys got carried this way. A massive school of glowing lanternfish. What's a lanternfish? Oh, the ones with the big eyes. That is funky. Oh, you can't see that. Funky. So, a massive school of glowing lanternfish swims past. They must spawn quickly to reach such large numbers, maybe exponentially quickly. And it's highlighted exponentially here. Okay, we're going to be dealing with something exponential, obviously. You should model their growth rate to be sure. Although you know nothing about this specific species of lanternfish, you make some guesses about their attributes. surely each lanternfish creates a new lanternfish once every 7 days. However, this process isn't necessarily synchronized between every lanternfish. One lanternfish might have 2 days left until it creates another lanternfish. I'm just going to call them fish from now on. It's weird saying a lanternfish so many times. While another might have 4. So you can model each fish as a single number that represents the number of days until it creates a new fish. Furthermore, you reason, a new fish would surely need slightly longer before it's capable of producing more fish. 2 more days for its first cycle. So, suppose you have a fish with an interval timer of 3. After 1 day, its interval timer would be 2. After another day, its internal timer, why am I saying interval timer? You have a fish with an internal timer value of 3. After 1 day, its internal timer becomes 2. After another day, its internal timer becomes 1, and then 0. After another day, its internal timer reset to 6, and it would create a new fish with an internal timer of 8. Once every 7 days, a new lanternfish would surely need slightly longer before it's capable of producing more. And we're counting from 0, so that's why it's... I don't quite understand. After another day, the first fish would have an internal timer of 5, and the second fish would have an internal... Oh, I see. It resets. So it starts at 3, then it resets to 6, but new ones always start at 8. So the initial set of fish start at 3? Is that what that means? A fish that creates a new fish resets its timer to 6, not 7, because 0 is included as a valid timer value. The new lanternfish starts with an internal timer of 8 and does not start counting down until the next day. Realizing what you're trying to do, the submarine automatically produces a list of the ages of several hundred nearby fish. Oh, so we get the ages of the initial fish. For example, suppose you were given the following list. Well, here's our example puzzle input. So that's going straight into our input day 6. That's going straight into our input day 6.text. This list means that the first fish has the second fish, blah 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 blah. So there's your initial state. So basically we're kind of ticking down each day. A 0 becomes a 6 and adds a new 8 to the end of the list, while each other number decreases by 1. In this example, after 18 days, there are a total of 26 fish. Find a way to simulate lanternfish. I'm going to copy this, and this is I'm going to create a file called example day 6.text. I just want to copy that. Let's open our day 6. So let's read our input. So we're going to use, we need to include our input helper, and then we're going to read our puzzle input, which is going to take input day 6 text, and then it's going to take a count. So we're going to need int fish count, and our list of fish int fishes max day 6 fishes. I'm going to define that and this is going to be exponential. So I'm just going to create like quite a big number. No, even bigger. 32. It's just a really big number there. Okay, so we need to pass it our fish count and our fishes, and we're just going to scan an integer list, which I think at the moment this is scanning. Well, let's print it. Printf. Let me open our example day 6, just so we can sort of copy initial state, and then for int I from 0 I, or rather fish I is less than fish count fish I plus plus, and then we're going to printf %d comma fishes fish I. Let's compile that. Missing an underscore there. That's too high. There we go. Initial state is 3, comma. Let me just also put the number of fishes. Fish count should be 5. It's not, it's 1, because this scan integer list is used for when the integers are line by line. So I'm going to create a new function here called scan integer comma list. I'm going to call this white space list. So our values is just our user data, and then it's going to return scanf file, and then it'll be %d comma. And we return. This returns a positive number if it did find something. So where we use this, it was in day 1. So this is now scan integer white space list, and in our day 6, this is now scan integer comma list. So there we go. Initial state 5, 4, 3, 1, 2. So let me just open my example 5, 4, 3, 1, 2. So let me get rid of that. Oops. You know what? If fish I is equal to fish count minus 1, just because, just so it matches it exactly, we don't do the comma. There we go. Okay. Now we just need to do advance fish day, and it takes in our fishes and our fish count, right? So to advance our fish day, because we have the potential of adding extra fishes to the end of the line, we could go from it backwards, or we could just cache this fish count. So basically int today fish count equals our fish count. I'm still going to do it backwards. It just seems to make more sense. So fish I is equal to our today fish count minus 1, while I is greater than or equal to 0, while fish I, we will decrement fish I, the fish index. And then our fish I, we will decrement them. Well, first of all, we need to check if our current fish is equal to 0, then we add a new fish. Spawn a new fish, right? Otherwise, we decrement its value. So if we spawn a new fish, which is 3210, it says, remember, we need to set it back to 6. So I'm actually going to define the values up here. So I'm going to say day 6 spawned fish age is 8. Let me go back to the new fish starts with an internal timer of 8, but sort of a fish that has just reproduced. Is 6. So we got these two numbers here. So our fish I becomes our reproduced fish age, and then our fishes fish count. So remember, the fish count can also be used as an index to the last entry in our list of alive fishes. So we have like this really big list of values, but we're not using all of them. We're all using a subset of those values up to fish count. So this is pointing to one after the very last one that we're actually using. And this will now equal our day 6 spawned fish age, and then we're going to increment our fish count. By 1. Right. Oh, I forgot to do the decrement up here. So notice we cached today fish count. So this never changes. Actually, we don't need to cache it, because the first section of a for loop only ever gets evaluated once when the for loop first initializes. Yeah, fish count minus 1. Otherwise, we decrement fish I. And then we just need this returns the day. So we pass in the day number, and we basically just return day plus 1. Right? So I'm going to say here day number is 0. Do we need to do that? Nah. We don't need to pass in day, because I'm going to do this as a loop down here. This becomes day. So day 0. We want to do 18 days. This I'm going to pull out into its own function called void print fishes. We do need our new line here. And it's going to take in our fishes and our fish count, which isn't going to be a pointer because we don't mutate it. So here we can do print fishes, fish count. We're going to advance our fish day, which again we have our fishes and our fish count. We do want a pointer to that, and we're going to print f after percentage days. Then we're going to print our fishes. And the new line. So we do have an error. Yeah, we don't want that anymore. Fish I is greater than or equal to 0. What? Oh, this needs to be our day. Oh, we don't need to print a new line because that's inherent in print fishes. This is day plus 1. So after 1 day, we got 23201, 23201. After 2 days, we got 121608, 121608. After 3 days, we got 01056780, 01056780. Let's go there. Go all the way down to 18 days. 606456, 606456, 0112601, 0112601, 112233, 112233. 467 quadruple 8, 467 quadruple 8. So that looks like it's working to me. After 80 days. So it wants to know after 80 days. So again, I'm going to define this. Day 6, days to advance is 80. So this becomes day 6, days to advance. And then there are %d fishes, and we're going to give it our fish count. Run it. So day 6, there are, day 6 of Advent, well, after 88 days, there are 5,934 fishes. 5,000. So, let's get our puzzle input. This is going to be a big number. Let me just see, what is 1 shift 16 bit shift calculator? It's only small one, isn't it? So what we actually want to do is our fish count is going to be an unsigned integer, because it would never be negative. So basically, wherever we have our fish count, I'm going to make it unsigned. Unsigned. Because this is now unsigned, it can never be below 0, so basically we have to say if fish I is equal to 0, then we break once we've actually handled the 0th index case. There's our unsigned. This might as well also be unsigned. I have a feeling our our puzzle input, our input helper also needs to use unsigned here. Unsigned here. Unsigned here and unsigned here. Oop. Let me just look for int. Yeah, that can still be int, but that needs to be int. Unsigned, unsigned. Good. So if we open our input day 6, I'm not going to print all that, I'm just going to print fish count. This becomes U. This becomes U. Right. Let's get. Oh yeah, and then this needs to be 31. our puzzle input. Copy you, paste, compile. Passing argument for from incompatible pointer type. Exceeds maximum object size. Yeah, this is too big. Just do like 28. And then this is actually, we've broken day 5. And that's because this needs to be unsigned int count. This also needs to be unsigned. There we go. So let me go back to day 6 and run it. And we have stopped working. So let's just make sure that, oops, not you, comment you out, stopped working still. Let me open our main.c. We are only running day 6. Let's just put this back to 16. Maybe we've just got too many fishes. Let's try 20. You know what? What I'm going to do is not at the moment I'm creating this array on the stack, and it's probably way too much data to on the stack. So we'll go use good old calloc. Actually, we could just use malloc. That's fine. So this is going to equal an array of ints, malloc, size of int. And then we need to remember to free our fishes, which we'll do here. Too many arguments to function malloc. Oh yeah, that needs to be times. You know what? Make you an unsigned int as well, because the age of our fishes can never go below 0. So we do just need to update you everywhere. Dash your count greater than width of type. Really? I just want like a million fishes. No, that's wrong. There's way more than 300 fishes. Let me now uncomment you. Because it will explode. Okay, that's working now. Oh, because we weren't advancing our days. And it only doesn't explode as much as I thought it would. But it is saying 38,000 380,612. 380,612. That's the right answer. Alright, part 2. Suppose the lanternfish live forever and have unlimited food and space. Will they take over the entire ocean? After 256 days in the example above, there would be a total of... What is that? 26 billion. So what's that? That's 1 billion. This is... So I think we want a long int. Yeah, so an unsigned int can only go up to 65,000. So we want a long int goes up to... Sorry, can you see this? A long int goes up to 2 billion. An unsigned goes up to 4 billion. What did we need? 26 billion. There we go. So we need an unsigned long int. And that goes up to an incredible amount. So here's what I'm gonna use good old type def. It's a big number, which is an unsigned long int. Or rather, I'll call this a U64. So it's I think it has to be U64. And this, we actually want that to be U64. U64. Yeah, I'm just going to do U64 on all of these. And I might have to also this is an array of U64, size of U64. So our input helper. Now also, so I'm going to move that type def to the input helper, and now this becomes U64. This needs to be there. So we now have in day 1, our values count needs to be U64. In day 5, our line count needs to be U64. Same here. So we're just going through until we can fix our inputs. So if we run this, this looks wrong to me. This looks very wrong. What was our answer before? 380, 612, and now it's gone all weird. Let me go. Do we need the int there? Is that like redundant? Yeah. Initial fishes. Oh, it's probably yeah. Is it UL? I've forgotten how to print. Sorry, wrong tab. So C printf unsigned long percentage LLU to print a long unsigned. So that was just a printing error. I'm still getting weird. There are 2133. Oh, God. Oh, that's annoying. So it looks like, because I'm on Windows, it's actually this. No? Or is it D? Let me go back to our our day 6 input. I don't want to print those. I want to say initial fishes equals percentage, and then fish count. I want to see what the initial fish count is. Don't make me count. Well, to validate it. But I will delete it and just do like 5 values. Initial fishes equals 5. Initial fishes equals 300. After 1 day, 450 fishes. Just because, so our max fishes is going to be 63. Let's overflow, or just 32. Really doesn't like you doing that there, does it? It's possible this is compiling as a 32-bit app. I'm not sure, you know. See, now it doesn't even like that. Like 2 billion is what? This. Include int types. I am going to do this. My number is d bytes wide, and normal num equals 4. Fish count, size of fish count. Let's run it. My number is 8 bytes wide, which is 8 times 8 bit 64, and its value is 300. Let me get my initial state then and see if this is valid. So we're going to get our input day 6. There's a valid state, and we're going to do this for 256 days. It's interesting, it just caps out. Or is it still running? It's still running. And it's eating up a lot of memory. Look at this go. Yeah, I know it's stopped working. Am I approaching this entirely wrong? It's like a mathematical trick. Of course, we can collapse. Yeah. There are 2 fish with the age of 3. So we can put them into we can sort of treat them as their own fish. And we can put them into their own bin. So essentially what we would have is we would have a 0 bin of fishes, a 1 bin, up to the maximum age, which is 8. And each bin would count how many fishes are in there, and we basically end up moving fishes to the various bins. So I would have like a define day 6 max fish age as 8, and then we would let me think about this. We would create our bins. So it would be fish bins. There's going to be max what did I call it? Max day 6 max fish age. So with our initial fishes, we'll do fish eye is less than and we will use U64 for each of the bins. Start using U64 now. Is less than day 6 max fish age. Fish eye plus. So we look at our fishes. So that becomes our age. And notice this now doesn't have to be U64, it can just be int. Size of int, max fishes, like the max initial fishes, we'll just say 1,000. I'm going to day 6 max initial fishes. There we go. Day 6 max initial fishes. I can go away. So we get the age of each fish, and then we basically say in our fish bins age plus plus. Right. So if age is less than or equal to day 6 max fish age, then we'll do that. So this is actually our fish count. This is going to be our initial fishes. And there's our fish bins. Let me just get rid of all of you. And then we free our initial fishes. Initial fishes equals 5. So now this will take in our fish bins. And it'll only need that. So this would be our fish bin I is equal to our day 6 max fish age. This can now just be a normal int. We can do the check if fish bin I is greater than or equal to 0. Get rid of this break here. So we're basically going to move the quantity of the fishes down. So all the fishes in fish bin 8 get moved to fish bin 7 and so on. So basically like fish bin I her -1 becomes fish bin I. We do need to check if so if fish bin I, so once we get down to 0 we have a certain case, otherwise we do this. We also need to cache, because we're overwriting the number in the one lower than that. We need to cache it. So one way we could do is say age equals day 6 max fish age, and then our U64 fish count is equal to fish bins age. Yeah, I'm going to change the way this works. So while our age is greater than or equal to 0, if the age is equal to 0, we'll handle that logic later. Otherwise, we're going to say our fish count is equal to fish bin I age minus 1. Fish bins, sorry, that should be fish bins. Age minus 1 is equal to, yeah, sorry, we need to do like a temporary int temp, sorry, U64 temp. So we're just going to temporarily store that in a variable. So it's kind of like a swap in a way, except we're doing like an 8 long swap. Becomes fish bins age but then when we do the next iteration, actually no, we want it to equal fish count, and then fish count is going to equal temp. Right. So when we get to 0, we're going to say fish bin day 6. We can get rid of this spawn fish age because we've got that in max. So our max fish age, we're going to increment that. So our fish bin 0 we decrement, and our fish bin day 6 reproduced, this age will increment. So this is where we spawn a new fish. Let me check if this logic is correct. Let me also reset this back to 18 days for the first example. So while age, and then we will decrement the age. So basically, let's say we had 1 in the 0 bin. So we have our 0 bin, and we have our 1 bin. Got 2 in there, and our 2 bin. Oh, we got 2 in there. We'll just consider like the max age is 2. So what happens is we start off with our fish count. So our fish count is going to equal 2, and then our age is going to equal whatever our max one, which is 2. So it's going to store our temp value of age minus 1. So it's going to, hang on, let me do 1, 2, 3. So it's going to store this free fish in that are age 2. So yeah, it's going to store there's 2 fish that are age 1, and then it's going to set this to free, I just realised we then need to say fish bin's age is equal to 0. Whoever's the oldest age we then need to set to 0. So it will then set this to free. Hang on. So our temp fish count equals 3. And then this, our temp is going to equal 2. Then it's going to set this to 3. This will be 0. And then it's going to decrement age. So our age is now looking at 1. So it's going to set our temp to age 1. So our temp will become 1. I think this is the wrong approach, you know. Because then it's gonna move this 3 Oh, actually no, it's gonna, yeah, because we set our fish count then to temp, right? So let me do this again. Our age equals 3, right? Our age equals 3. So the first loop is going to set fish count to 3, and it's going to set bin 2 to 0. Then it's going to set temp to this value. It's going to set bin 2 to 3. And it's going to set temp. It's going to set fish count to temp, which is 2. Then we're going to decrement age to 2. It's still not equal to 0, so it's going to set temp to 1. It's going to set 1 to our fish count, which is 2. And then it's going to set our fish count to our temp, which is 1. And then if our age equals 0, we don't want to decrement the fish bin, but we do want to increment, say, like 1 as our reproduce rate. That becomes 4, and this becomes 1. No, we want to increment it by our fish count. Basically. Yeah. That's it, I think. This print fishes just doesn't work anymore, so I'm going to delete it. So we're going to do our days. Let me get rid of all this. So our days to advance. So this populates the initial fish bins. And then we need to count fishes. So this becomes our U64 get total fish count, and this will take in our fish bins, and let's do U64 sum, and for is less than sum plus equals fish bin I, and then we'll return our sum. So that's to get our total fish count. Our max fish age. So we're setting up fish bins, max fish age. This actually needs to be +1. And then this becomes our get total fish count, fish bins. And then we need to advance. So again, this just becomes fish bins. Fish bins. That is entirely incorrect. And I think that's because we need to initialize our fish bins to are equal to we need to initialize them to 0. After initial fishes equals 5. After 1 day is 5 fish, 5 fish, 6 fish, 22 fishes. So let me check from our initial. After 18 days there were a total of 26 fish. So initial state 5 fish. It should go 5, 5, 1, 2, 3, 4, 5, 6. 7, 9. So that's not 5, 5, 6, 7, 9. Oh. $26. Interesting, it's not quite working as I would expect. It's almost as if like I need to pre-advance it for a 1 day. And I don't know why. Let me I want to print the fish bins. Yes, it's doing I64U. Try that. And then printf new line. So after the first day, we've got 1 0, 1 1, 1 2 2s, and let me open our example of day 6. So look, we got 1 0. It's a really weird way to read it, but 1 0, 1 1, 2 2s, and 1 3. That is correct. Then after 2 days, we should have 18, 16. So what's that? 1, 2, 3, 4, 5, 6. Oh. Haha. I was missing less than or equals to max fish age. Because this goes one past. That was the problem. So after 18 days, 26 fishes. Yes! Alright, let me get rid of you. Wait. Get rid of you. Yes. So after 80 days, uh, 5934. I remember that being a thing. Yeah, 5934. After 256 days, we've got this number, which I'm gonna copy and copy you and just compare it. Yes, it's working. Okay, so if I do input day 6, get rid of you, and get our example, actual input, sorry. Again, I just want to validate with 80 we're getting the right answer. So go down to the bottom, we got 380612. 380612, and now 256, going to pile run. We've got this whopper of a number. Let's try and read it. So we've got, what is that? 1,710,166,656,900. That's a lot of fishes. Okay, that was a fun one. Yeah, I like how it kind of threw me in a loop in part 2. Yeah, I thought it was weird that I was going down the line of making sort of bigger integer types, because it's so like language specific as well. So yeah, it makes sense that you sort of have to think about it in a different way. That was cool. That was a good one. Man, I need to lie down after that.